When I was talking with Jack, the other GE Additive employee I've gotten to know over the past few weeks, he mentioned that additive is more of like a complement to traditional manufacturing. They kind of always will work hand in hand. I was wondering, do you think additive can ever fully replace traditional manufacturing, or do you agree it's something that they'll just go together?
Yeah, I think I agree with Jack. It's going to be an additional tool in our tool belt. So I think that there will definitely still be applications where you'll want to go the traditional manufacturing route. And that could be for cost. It could be for lead time. So conversely to what I said earlier, if you have a part that's really easy to machine out of a forging and you're only machining a few features here and there, that might be a little bit cheaper than printing a very large structure. I think there will still always be the need for traditional manufacturing processes. And even with additive, there are a lot of cases where we'll also post-machine additive parts. So I think there's still always going to be a role for machining processes in general, just because some of these applications require very, very, very tight tolerances that just based on physics is going to be near impossible to get to with additive. I think we can improve, but I just don't think that there's ever going to be a time where we can print a surface finish of, 32 microinches RA. So yeah, I think there's always going to be a role for both.
So how do you envision some of these more computer science heavy concepts like machine learning and AI being incorporated into 3D printing technology in the future? And if so, how do you envision that's going to look?
There is definitely a lot going on around machine learning, in situ monitoring, a lot of development being done so far. And there's still a lot of development left to do, to be honest with you. But I think there's a lot of potential for reducing cycle time, both on the production side and on the development side. So as we get smarter about how, especially with a laser or electron beam application, as we get smarter about how weld pools are formed and melt pool theory and how we can then bake that into machine learning and tools like that, the development time should go down. Anytime you introduce a new alloy or want to make a new parameter, you already understand how the melt pool should form. And so that will then help you, just be that much further along in your development cycle. In terms of using it in production, there's still a lot to be figured out around making the process repeatable and reliable. Mm-hmm. So what happens when you detect a defect? So will you actually change your process? And are the regulatory bodies going to be, especially in the aerospace industry, are they going to be okay with a potentially different process in every build? So I think there's still a lot to be considered and a lot to figure out. But maybe in some other industries where you don't have quite the rigor of, heavy regulatory bodies, there could be applications where, you detect a defect and on the next layer, you might change your melt pool in that one specific area and hopefully be able to heal it. But then how do you inspect for it? How do you make sure that that defect was actually healed? So I think there's been a lot of exciting development. I think there's a lot of potential for it, but I think there are still a lot of big questions that are going to have to be answered in terms of repeatability and stability.
So do you think it is possible to use this in situ monitoring to catch defects like right on time? Because you were just saying that it's going to be difficult to be able to actually see if you did catch it and if you made the right changes to either cut off the process or adjust as necessary.
Yes, there will be a couple of different ways to detect a defect during the printing process. So one way you can do it is to detect a disturbance in the powder bed. So as you lay down the next layer of powder and you see a spot that didn't fully get covered with powder, there might be some sort of divot or hole there, or just some powder that didn't stick. So that's one way you can actually detect it. Another way is looking at the parts that have already been welded. And if you see a discontinuity in how that particular section of part welded compared to the section of part next to it, sometimes you can see those anomalies with the naked eye even. In terms of detection, I think that, there are several methods out there. But then to your point, how do you then adjust the process for it? And I think that's where there's a lot of room for development. How would you then heal that defect? And then there would definitely have to be a lot of validation on the back end as well during that development to make sure that defect closed up, whether you take the part and CT scan it or x-ray it, or do some sort of non-destructive or destructive testing to figure out whether that defect was healed or not.
Can you currently put cameras within the machine? Doesn't it reach super high temperatures? Is that being used right now?
Yeah, so GE Additive even has options out there for these cameras to monitor the process. The increase in heat is pretty localized. The chamber itself won't get super, super hot, really just at that weld pool that you'll see those really, really hot temperatures.
Gotcha.